Here's another projectile question, and for this problem we have a stunt vehicle leaving an incline with a speed of 35 meters per second at a height of 52 meters above level ground, and there's no air resistance for this problem. Okay, so for the very first part, I need to find the vehicle's vertical and horizontal velocity components as it leaves the incline. Okay, so in this particular question, we have to recognize that the 28 degrees is right here, so 28 degrees. And if we're at point A, which I'll label this as point A, so at point A, we have a vertical velocity component, and we also have a horizontal. We have a horizontal velocity component right there at point A right there. Okay, so we're going to find Vx and Vy to start off this problem. Now, if I want to find my horizontal velocity component, it's always going to be the speed that we're taking off at, which is 35. So it's going to be 35 times cos of the angle, so cos of 28 degrees. And if I round that to 3 decimal places, I get 30.903 meters per second. And for my vertical velocity component, that's going to be 35, which is the initial speed, times sine of the angle, so sine of 28 degrees, and that equals to 16.432 meters per second. Okay, so that's it for part A. That's the vehicle's vertical and horizontal velocity components. Part B is more of an interesting question. What is the vehicle's time of flight? Okay, so I gotta find the time of flight for this particular problem. And before I start the time of flight question, let's go ahead and label this diagram one more time. So we start at position A, and then we get to a maximum position at B, and then we finally end at position C. So we need to find the time it takes from A to B, which is going in the upwards direction, and then we need to find the time from B to C, which is going in the downwards direction. Okay, so a few calculations that we need to do to find the time of flight for this projectile question. Okay, so let's create some space here. So if I'm going from A to B, this means we're going in the up direction. Okay, and our initial speed is equal to our vertical velocity component, and we did calculate that in part A, and that's going to be 16.432 meters per second. Okay, and once we get to point B, that's the maximum height, so our final speed at a max height is going to be 0, and our acceleration due to gravity, since we're going the upwards direction, is going to be negative 9.80 meters per second squared. And there's two things that I need to find from A to B. One is the time it takes from A to B, and I also want to find the total distance it takes to go from A to B. Okay, so the kinemax equation that allows us to find time is going to be our final speed equals to our initial speed plus our acceleration times time. Okay, so our final speed is going to be 0. Our initial speed is going to be 16.432 plus bracket negative 9.80 times the time. Okay, and our goal is I want to solve for t, right? So if I bring this expression to the left-hand side, I get positive 9.80 times my time, and that equals to 16.432. Then I can divide both sides by 9.80, so 16.432 divided by 9.80, and it turns out that my time is going to be 1.677 seconds. Okay, so my time to go from A to B is 1.677 seconds. Okay, let's go ahead and erase this now, and now I want to find the distance, the total distance traveled by this car from A to B. So now I need another kinematic equation here, and the one that I'll use is my final speed squared equals to my initial speed squared plus 2 times the acceleration times the distance. All right, so there's my kinematic equation right there. My final speed is going to be 0. My initial speed is going to be the 16.432 to the power of 2 plus 2 times negative 9.80 times the distance there. So I need to find my distance. Okay, and if I bring this term over to the left-hand side, that's going to be positive, right? So that's going to be 2 times positive 9.80 times my distance, and that's going to equal to bracket 16.432 432 to the power 2. And the goal is to solve for the distance right there. And if I go ahead and solve for the distance there, I got to pause the numbers here. So 16.432 all squared, and we divide that by 2 times bracket 9.80. And if we go to a calculator here, we get 13.776 meters. Okay, so a few kinematic equations right there to find the time from A to B and the distance traveled by the car from A to B. Okay, now let's go back to the diagram here, and let's just kind of put in what we just kind of calculated here. So from here to here, that distance right there, that was the 13.776 meters, and the time it takes to go from A to B. So B is right here at the top. So the time that it takes to go from A to B is going to be 1.677 seconds. Okay. So now we need to find the distance, the time it takes to go from B to C, and then we can add that to the 1.677 seconds, and that will give us the vehicle's time of flight. Okay, so we're almost there. Okay, now let's look at this projectile from B to C now. And from B to C, we're going in the downwards direction, right? And since we're falling down from B to C, our initial speed is always going to be equal to 0. Our acceleration due to gravity is going to be positive 9.80 meters per second squared. And then we can also find the total distance traveled from B to C. Now we know that the initial height that this car is standing upon is 52 meters above the ground. So the total distance from B to C that we travel is going to be the 13.776 plus the 52 meters. And that total distance that the car travels from B to C is going to be 65.776 meters. Okay. Okay, after that, I want to find the time that it takes for this vehicle to go from B to C so it hits the ground. Okay, so the kinematic equation that relates all this together is going to be the distance equals to the initial speed times the time plus 1/2 AT squared. Okay, so the total distance traveled here is going to be 65.776, and that equals to, well, your initial speed times time, well, that's going to be 0 times the time plus 1/2. And my acceleration due to gravity is 9.80 times t squared. Okay, so we know this just goes to 0. And then if I want to get rid of this 2 here, I can multiply the 65.776 by 2. So this will be 2 times 65.776 equals to positive 9.80 times t squared. And then I can divide both sides by 9.80. If I divide by 9.80, that goes away, and then I can just square root that and square root that, and that will just give me the time there. Alright, so time is 2 times the 65.776 divided by 9.80, and we just square root that. And if I square root that, I guess I would get a time value of 3.6638 seconds. Alright, so 3.6638 seconds. Okay, so going back to my visual diagram here, let me just erase all this. Okay, so what we just kind of figured out, from B to C, the time that takes for this projectile to go from B to C is going to be 3.6638 seconds. Alright, so going back to part B now, what is the vehicle's time of flight? So we're simply just adding these two numbers together from all the way from A to C, right? So if I want to find the vehicle's time of flight, it's going to be 1.677 plus the 3.6638, and that gives me roughly 5.341 seconds. Right, so that is the vehicle's time of flight right there. Okay, final question is I want to find the vehicle's range. Okay, so if I want to find the vehicle's range, I got to erase all this. And let's just go ahead and figure out how we can calculate the range here. So basically the range is this bottom part right here in green. Alright, so we want to find the range right there. So if I want to find the range, there's a very nice formula for the range here. So range is really equal to your horizontal velocity component times the time of flight here. So Vx, we actually did calculate back in part A, which is the 30.903. Oops. 30.903, and then we multiply by the total time that the vehicle is in the air, which is 5.341 seconds. And if we go ahead and multiply that out, I guess I get around 165.0478 meters. So depending on how many decimal places that you use in your calculations, you should be somewhere close to this particular number. As long as you have the right concept, it's your horizontal velocity component times the answer that you had from part B, which is the vehicle's time of flight. That should definitely give you the range right there. Okay, so that concludes this homework video guide.